Welcome everybody. Hope you're having a good day so far. So, I had an idea for a stream here, and I thought it'd be a good continuation of the last episode. I'm not going to spend too much time going into the next days and weeks doing these types of PDF processing videos, but I do think it's a good way to demonstrate and to explain my thinking process and to make some points that I've been meaning to make. Let me click this button to make sure we're live on Rockfin. So welcome everybody. Okay, so let me just kind of do a little overview here before we dive into today's objective. What I'm trying to do here is just build up the arsenal. And I think these are incredibly powerful tools that I personally was sleeping on. And I'm imagining that other people out there might not have this information. And so if this doesn't pertain to you, definitely, of course, feel free to click off. I'm trying to get this information to people that I think need to hear it. And that may or may not be you. So, I always like this least squares regression in school. I don't know if you remember this, just in general, not just in school, but where you have a number of data points and you're trying to explain it with an equation. And the way you find the best equation is you try to find the best curve or the best line, or if we want to be technical, continuous function, that when you take the measurement called least squares, when you take the squares of all the residuals, it's the least. Out of all the different choices, what's the least squares? And, there's different ways that you could theoretically define a success and the best line. You could say, well, I want it to go through as many points as possible. But then you're sacrificing other things. You're missing the opportunity to get as close as possible to all of the dots. So I think many of us would agree that the least squares is a good way to determine what's the best fit, the best line to go through. Now, the issue with this, if you've ever tried to do regressions using mathematics, you're limited in the type of equations that you can use to cut through your data set and try to get as close as possible, right? You can draw a line, you can draw a parabolic curve, you can do exponential. There's a number of different things. And then once you have multiple variables, it gets incredibly complex and almost impossible. You could see a very clear pattern on the page, but it's like, how do I express this as a function? For example, this is one that I recently solved. It's pretty easy to do with a neural network. Come up with a regression to explain this curve here. And if we didn't know the equation, which you can see up here in that text box, just the sine of x plus the cosine of y, we look at this, we definitely see a shape to it. There's definitely a pattern to it. But we can't really tell somebody. I mean, we could look at this curve and try to guess where the z would be for any x and y. But it's very hard because it's like, okay, we can't draw a line through these. We can't draw a parabolic curve. So what I like about the neural networks is under the what's the term, the cover, under the hood, it's a bunch of linear expressions, equations, but it can explain very complex continuous functions, and we don't really have to think about how it's doing it. And oftentimes it's kind of a black box. We don't really care as long as it's doing it well. So I'm just trying to build the arsenal up, and now I'm seeing things completely different. When I see a problem, I'm like, oh, well, we actually have tools that we could solve this. So one problem that I've been grappling with is how to crop out the key sections of a book page. Oftentimes there's like page numbers or, text at the top of the page, which I'm not too interested in a lot of the time. So kind of my makeshift solution was to build this page here, which I've shown a number of times. Yesterday I showed it was kind of buggy, but I've ironed out a number of the bugs and it's getting pretty close. And this works pretty good, except for I've got to go through and adjust and get each page correct. And I can come up with rules that will save me time, which is great. And this might be the best I'll be able to get. But yesterday I showed somebody emailed me this library and it looked really great. It came recommended from the person who emailed me. And I saw like 10,000 stars on GitHub. So I was like, let's just do a live stream. I was hoping it would go better than it did. I think we covered a lot of great stuff about how to use ChatGPT to solve our problems and to get up and running with new code and write code and debug code. But the actual library that we found didn't work too well in my assessment, my review. So I just kind of wanted to update here. I'm not recommending that package from yesterday. We were just trying it out. But I do like their methodology and their approach. They were using machine learning to try to get the segments of the page. And so it got me thinking, and I thought we'd give this a shot in another approach here. How can we do this better? And so I asked ChatGPT, see if it had any ideas. And it recommended something called Faster RCNN. And I'd seen CNN before because I've been studying all these different neural network types. And it stands for Convolutional Neural Network. And it has to do with image recognition stuff. And basically the way it works is before it turns into a pretty standard neural network to try to find patterns, it first extracts all these features from an image, doing a set of filters and transformations to the pixel data. And so I was thinking, okay, that might actually be interesting because there's other ways to do this. For example, if we're looking at these pages, there are ways to zoom in. There are ways to do like OCR, which might not be perfect. I mean, what I really like is the new ChatGPT 4.0 OCR is pretty good. And then there's like Amazon Textract, which might be the best the best value for something like English. And this is a key problem because we have tons and tons of PDFs, thanks to sites like Anna's Archive, Wikimedia Commons, what else? The Internet Archive. And there's overlap between a lot of these. The Library of Genesis, et cetera, et cetera. So a key problem that I have is I've been collecting these PDFs and it's like, this is too much to read. And I also really like to have different forms of consuming the information. So one key bottleneck is I need to get it in text format first. And then I can consume it in a whole bunch of more interesting ways. We can use low-cost LLMs to kind of guide us to the right parts in the book or to ask us questions and based on how we answer, tell us where to go in the book and what to read. And I also like hearing stuff spoken out. And these text-to-speech models are getting better and better and better. So I find it an interesting problem here and one that I definitely need to solve just because of my backlog of books I want to read. So there's different ways that we could go about trying to use a neural network to help us draw these bounding boxes. And one thing I wanted to try before we get into this, well, let me explain the different ways that we could feed into the neural network. We could just get a measurement at various positions in the page of how much black ink there is versus white ink. And somehow use that to see, okay, we need the neural network to tell us how many columns and the X, Y, width, and the height of each of the columns. Or we could do some sort of OCR on the recognized words. We'd look at their positions and then feed all of those into a language model. I think that'd be another interesting way to look at it. And I feel like a lot of this is done, not the OCR word position stuff, but as far as the composition of the pixels in terms of the black-white ratios and such. I'm hoping that that'll be done by this model here, Faster RCNN. So I wanted to try this out and just kind of show how we can learn about a new model or learn about a new library or whatever, even in a language that we might not be extremely proficient or fluent in, and use ChatGPT to just do the legwork, the grunt work, and just spit out a bunch of code for us and just try it out. It's very low risk. I mean, it's a low cost at this point because we don't have to slave away over our keyboard, hitting it 10,000 times or more to try this stuff out. We can just try it. So I've been super impressed by the feed-forward neural networks, and that is a part of the faster RCNN. After it detects the features, it feeds it into a feed-forward neural network. So I wanted to try this out. Let's start here by making a new project. I like this approach for using ChatGPT. Feel free to use it on your own. Basically, I use something that I call placeholders. So I use file placeholders or function or class placeholders. Although most of the time it's just the whole file. So you could really do a simple version of this. Let me show you. So we'll make a new project. We'll call this RCNN book segmentation. And I was thinking before the stream, and this is why one of the reasons why I like to do this is because I come up with more interesting ideas faster when I do live streams and make it public. And sometimes people will reach out with ideas, which is always recommended. My email is timtruth@protonmail.com if you want to collaborate or if you have any tips that you think I should hear. So let me find what I just did here, RCNN. So we load this up. Okay, so now I have a folder that I can start filling up with files. We'll come back to this. But before we dive in, let's try just going to ChatGPT through their sandbox, which is a cool tool if you're trying to figure out the API, and you can even try like their vision capabilities through this. So it's, I think, playground.openai, or what is it? Let me just search. Need to log in. Okay. So this is a good tool for when you're using ChatGPT through the API. It'll help you find the code that you need to use. And also it'll allow you to do like system instructions, which is a very powerful tool that you don't get access to when you're using the web, chatgpt.com. So, for example, the system instructions, I could say, you are a helpful assistant. That's like the typical system prompt. But then I'll add who responds only with the text of the image provided, accounting for columns and providing the text in a cohesive format that matches how one would read the content. And then what we could do is find an example with multiple pages. This one's an interesting one because it has Greek in it. And we will get the URL to use here. Copy this image. So I just wanted to see, because I was thinking, do we even have to crop it by columns these days? I mean, back in prior versions, we definitely did, but it might be smart enough. So let's just paste this here. And then I'll say, what is the text in the two columns on this page? Provide the contents in a seamless format with the left column contents followed by the right column. And let's try it. And also I want to turn the temperature down. Just turn it all the way to 0. We don't need it to be creative. And let's run it. So it's diving straight into the response. That's definitely not the whole page, though. Oh, sorry, the maximum tokens needs to be way higher. Let's remove this, try it again. That's what I was looking for. Actually, I'm thinking we need to just redo this. I mean, the vision is super powerful on this ChatGPT version 4. Oh. So let's run this again. Because this might just be totally unnecessary. I mean, it would definitely be helpful for Amazon Textract. Although even, I think Textract gives columns. I did a number of experimentations, and I think it, let's see, let's just go to ChatGPT. What is the response format from Amazon Textract when a book page has multiple columns? So I'm not seeing anything jump out. I guess it's saying that it'll just be in a list of items. It'll start with the things in the left column and then just dive straight into the right second column. So that would work too. So maybe this isn't actually even needed, which would be great. Okay, let's see how it did here. So it starts here at this. It looks like that first character is wrong. But definitely better than typing it in, just finding where it gets things wrong. It's a little bit frustrating because, I mean, this is saying there's a W here. I know that's not actually a W, but that's a Greek character that I'm not actually seeing in any of these. So it seems to be making some mistakes here. Let's see the last word here. Yeah, it just seems to be all over the place here. It doesn't seem to be the highest of quality here, which is a shame. I was hoping that'd be better. Okay, but let's get back to the challenge at hand. I just wanted to do this as, if anything, more of a tutorial on how to use ChatGPT to code Python and use these PyTorch language models, which are really powerful and giving us, I mean, there's more and more base models for us to plug into all the time. And so I think we need to bone up on the ability to fine-tune these things. So let's try it out here. Let's go to my first question. I just asked, how can I train a faster RCNN neural network using Python and PyTorch to tell me the bounding boxes for the textual columns in a scanned book page? And what's great is I have a lot of training data. We're just going to use these two books. This one with just one column per page. Got to fix some of these. And the other one with two columns. And I was just curious how well it could do. Okay, so skipping this. It's telling me to make an annotations.json file with this format. So one thing I want to do, because I actually haven't touched any code yet in this regard. I mean, I've done a lot of PyTorch stuff, but nothing with faster RCNN. So I was playing around just doing queries to set up for the stream. And one of the other responses told me to use CSV. But I think the JSON makes more sense because it'll group the columns with the page. So let's just change this query that I already had. And this time we'll ask for JSON. So I requested in PHP format. So here's a script to transform the JSON data. It's done. So with both of these programming languages, PHP and Python, I can just go to my Notepad++, and we'll go to that new folder that I just created. And we'll call this columns JSON prep for model. And I like to, at the very top of my scripts, especially the ones that I run from command line, put just the command to run it so I can just easily copy and paste it whenever I need it. And we're going to need the JSON data, and I'm just going to also put a little note to myself how to get this from my other page, or excuse me, it's copy JSON stringify. And let's go back up here. So a great thing about using a web is it's super easy, even if you're on somebody else's page, to grab data using JavaScript. So in this case, I already have, trying to remember what it's called, rules, no, call, trying to remember, there's a variable name here. Let's look at my network, see where it loads it up. I think I'm using array table view. Might be the best way to find this. Yeah, right here. That's what I'm looking for. So I already have this data. I'm going to change this to, I think it's book to use. No, it's book name. There we go. So these are all these rules over here. So I have a start and an end page, and then I have the actual column cropping information. This is the key thing. And there's some rules to it about like the start and the end, and if it's odd or even only, or both. But what I want to do, and I really like this copy command. If you're in the console, you can just copy whatever data you're trying to grab. So we'll do this here. I just ran that in the console. And we'll put here call crop rules JSON data. And we'll make this a new file with that name that we just made up. Not that. Wrong name. Okay. And so then for include page ranges, so I don't think I read this query where I got this from, but this is how I like to use ChatGPT. So it's not very good at making an entire thing, an entire application or script that'll solve all your problems. But what it's really good at is if you give it like a constrained smaller task. So I gave it this JSON. I have JSON in this format that describes the annotation for column bounding boxes and scanned book pages. And I just gave it a bit of the example. Then I put ... because I didn't want to. I think it got the idea. And then I said, give me a PHP script that will transform this into JSON format for specified page ranges. And so I just basically made up this whole schema, whatever we want to call it, where I can specify the include page ranges. I was thinking of, you know how when you print out a document, you can say, give me pages 5 to 17 with a little dash. And then I wanted to also have just one-off include pages in a list, and then the same for exclude. And it came up with all of this, and it says should include the page. So actually, one thing I'm seeing that it's not doing is accounting for the odd and the even. So let's just put this in here because it's good just to eyeball the code it gives us and then see where it got it wrong. So we can say, you're missing the odd even specification as part of the rule definitions. Perfect. All right, so it gave us this. Actually, I think that was the whole code. All right, so I'm realizing I need to go get this file name again. That's one kind of problem with ChatGPT is, well, it's not a problem, it's totally understandable, but any changes that you make after you copy down the code and then you go back and you complain about something, you grab the code again, you have to go make those changes again. So sometimes it's good to start new conversations. Okay, so actually this is way more complicated than I actually need. I just wanted to give it an example with enough details that I could implement. But if we go back to, we're starting with the Aesop Fables. I really just want from page, this page is messed up somehow. So we'll start at 18 and we'll go down to however many pages there are. So something that I'm also wanting to convey here is my thoughts on how to use models in general to do the grunt work for a lot of data, because it's somewhat of an iterative process. And I don't think it's the right approach to, if you have, let's say, 10 million or a billion records that you're trying to sort through and handle. Okay, it finished here. I'll get back to that point. But it's 18 to 532. So we'll just put that in here before I forget. Okay, but my point is if you have, let's say, a billion records that you're trying to sort through and process, and you have a model that you're trying to train, one approach, one obvious approach, is you take a certain amount of the data and you manually annotate it or label it. Those are just terms of machine learning where you actually define what you want the machine to predict from that type of data. And you give it the answer key, and it learns from the answer key. And this applies to pretty much all the different types of machine learning, be it computer vision, or where you're making images using something like diffusion, or making audio, or making numerical predictions especially. This is important. But you don't just want to take 10,000 of the records, I don't think. Make a model and then use it and deploy it and then have to live with it for the remaining billion. And this, it depends on the size of the data, how involved you want to make the process. But I think a much better approach would be to design the process in such a way that as you're going through the model, once you train it with the first 10,000 or something, I think that's a good first step. But then you want to maybe predict for all the billion. And then you want to start going through and seeing what it did, and then make any modifications that you need to. And in a sense, it's like computer-aided annotation, computer-aided labeling. That first step that you had to do entirely by hand, now it's giving you a good starting place. For example, with these books, it could, if I have a billion pages of books that I'm trying to process, it could give me these bounding boxes for each of them. And then I could scroll through, and then there might be some mistakes. Like, this is a mistake here. I could realign it. And then once I get to the bottom of a certain section, I can click a button and say, good to go. All of these have been confirmed. Hopefully I didn't have to change them too much, and the model was a huge boon. It'd be a huge help. Another class of models that we've talked about before is text classification, using something like BERT or DeBerta. Same premises goes here. I think it makes sense to build a system-based approach where you train it first, but it's not done training. You keep training it, and you're building out this quality data that it's training on. And the quality data is growing in size thanks to the help that it's providing in the labeling process. All right, so let's give this code a shot here. So PHP can be run from the command line. That's why it's always good when you're writing PHP, even for server-side scripting, or server-side like the back end of your website. Say you have a number of functions, like for example, this book importer here. I have a lot of stuff that I have to do on the server side, like getting the sizes of the images, etc., etc. So I have there's a good pattern that I like to use, and that is I have a query file. The query file will handle all the requests, and then I have a methods file. And what's great about having these separate, and so the query file basically gets everything set up, checks to make sure everything's proper, all the required parameters are passed, and then it imports the methods file, and then it passes basically what came in from the website request to the server to the methods file, to the proper function. And then it gets the response back and returns that back to the client. And the great thing about this approach is that if you later have to do stuff, say in a cron job or from a script that you're running from a command line, or if you have another website that you want to make that uses the same functionality, you don't have to copy and paste it from, you don't have everything in the code that's specific to dealing with AJAX or HTTP requests from the client. It's good to separate things into not too many component parts, but the right amount so that things are discoupled and reusable. Same thing with like Python. If you're writing code and there's some key functionality that you want to be able to reuse in the future, which is a key goal that we should be trying to strive for when we're writing code. Usually if we're writing code, we want to be using it a bunch into the future. And if we put it all into one script, then you can either just run that script again, or you can copy and paste the script to make a new version of the script, or take some parts out and make a new script. But I think the best way to handle these things is in Python to make classes, reusable classes. And taking the extra effort to figure out how to do that and to actually do it is definitely worth the time, I would say. Same for PHP. Okay, so it said it made the file. Let's open this up. Okay, so we have all these images. And for each of them, we have these boxes. Now the problem here is this is the X, the Y, and I think there might be a mistake here because it's a little confusing what these numbers represent. Let's go back. It wants X min, Y min, X max, Y max. Let's just check to see if this is right. So we have this example here, page 171. Sorry for jumping around here. 171. Which is apparently rule number 5, which might actually mean 4 if you start counting at 0, which arrays do in JavaScript. So let's open this back up, the dev tool, Control-Shift-I, and we'll go back to this variable. I love the console for this type of thing because we can really dive in and see what's going on. So these are all my rules. If we go to rule number 4, because it starts at 0, so 1, 2, 3, 4, 5 gets us rule 4. Yeah, this is a single rule that's from 171 to 171. Perfect. There's a single column in here. Oh shoot, I'm not showing my screen. Actually, I might have been, actually. I don't know. But what I'm basically showing is that if you paste a variable that has an array or an object, you can explore it in like a tree format with collapsible nodes, which is really helpful. If you're programming web stuff and not using like the debugger or the console, you're really missing out. When I first started scripting at my first internship doing web development, I would put like alerts and I'd have like an alert pop up and they're like, you know about console.log, right? So console.log will print things down here. So all of these items here were put there by a console.log and it doesn't break the flow of the page. And what's cool also is you can click the icon or the link over here. It'll tell you where the console.log was, unless your Firefox is broken. Oh, here it is. Okay, so what I wanted to see is if we're matching what we should be. So the height and the width. Yeah, okay, awesome. So it's adding the top to the height. 4681 plus 484. Seems like that'd be about 5165. And that's the Y max. I'm just going off its recommendations here. And what's cool is we're not married to anything. We can just prompt it a little bit differently and be like, actually, we want it to be the top left, what is it? the point at the top left, the top and the left values, and then the width and the height, for example. But yeah, it says X min, Y min, X max, Y max, and that's what we're doing. So ChatGPT just worked it out. I mean, it's super smart. This is not just a typical chatbot. It can reason and it can just you can just throw JSON at it and say, okay, here's my data. Make me a script that transforms this. Here's the format that I want to be transformed into. That's what we just did. Okay, so let's go through here. Define the dataset class. So we'll just copy this. Here's dataset transformer. So one thing I don't like here is it says to make all these classes, then here's a training loop, here's testing and inference, but it didn't really give me the file names and it's certainly not including them properly here. So let's reprompt this. I'm too zoomed in, I'm sorry. There we go. So I'm going to reprompt this and say, you're not actually importing your custom classes here. Give these classes meaningful file names and import them properly. It's also going to be interesting to see if OpenAI has a big announcement tomorrow. Now I'm doubting it. I was thinking, I bet you they do. But now it's like, what are the odds? I don't know. I don't really care either way. But it is important to note that we've seen massive, massive developments both in the closed source and the open source stuff over the past year, 2 years. So if these trends continue, which is what all of these people in the research space are saying that they will, I think it's somewhat reasonable to expect and assume that these faculties are going to get better and better, obviously. And that is pretty amazing given what they can already do, to think about where. That's why I'm trying to, add it into my workflow and tell people about this, because it's already a little bit foolish for people who write code to do it all manually. I mean, I think it's great to understand how programming works, to be able to think through these things and do it manually. But I don't see any practical benefit. And I can see huge upsides and huge productivity gains from leveraging these types of technologies. Okay, so you see now that I told it to, it's telling me to create these files. So I'll do this real quick. Here is book page dataset.py. Here is transformers.py. So again, the cost of trying things out is much, much lower. And even if we scrap this or move on to something else, which of course we will at some point, the beautiful thing is I've got this code on my computer. I can revisit it at some point. If some other task comes up, then I'm like, oh, I've got to go finalize that, because I definitely need to use that at this point. It's there. And that's also why I really strive to make things reusable. Because if you spend that extra time and you get it to a point where it's super expressive, as they say, for using it in any custom script into the future, super easy to configure and to make it do what you want, then it just makes, it's pretty amazing. You're just building your own custom tools that you can always change and enhance later. But it's great to make them all plug and play, so you don't have to, it just saves you time. Okay, and then here's the main training script. I did see they put a lot of these types of like lazy comments. I guess it was mainly this one in utils. Let's just say if we highlight this and we do the reply quote there, I'll just say implement these functions, please. All right, so here's what I'm doing. I'm copying and pasting this. So we got 1, 2, 3, 4, 5, 6 classes here. So we'll call this run model training. And I hear a lot of people, and I really don't want to sound like an OpenAI fanboy, but I hear a lot of people say like, oh man, that's their new model is shit, it's terrible. And they say like, oh, some people just don't use any performance enhancing LLMs. And some people use other ones. I've gotten in conversations where people will say, oh, I use Mistral 8 billion parameter model. And I'm like, I don't really know what you're talking about. I mean, maybe we're doing different tasks, but I don't know what people are using that's better than this, frankly. This is just, it blows my mind that we can just get, I can sit down for a session and write 10,000 lines of code with the help of this thing. And it's pretty good code. But I do love that about humanity, that humanity's never satisfied. If you told people, many of these same people 5 years ago, that in 5 years there's going to be a tool that does all this and you just explain it all, they'd be like, no way, there's no way that's possible. It's a pipe dream. And then you tell them now, they're like, oh no, that sucks, man. All right, let's try it out here. I'm sure it'll fail. Okay, I have to change the, okay, no module name, Cocoa utils. I'm also realizing I need to change the paths to the images, my annotations file, etc., etc. So I probably have to do like a pip install. So, okay, Cocoa is a format for importing for representing annotation data, I believe. So I'm not sure where this is even being referenced or if it's needed. Let's see. utils.py get Cocoa API from dataset. I don't think we're even using. Do we even need to use Cocoa here? Also, let's see what this other script is here. Okay, this seems much more fleshed out. Copy this into place. So I just think it's pretty amazing that I can not have any idea that this model type even exists, or CNN. I knew CNN exists, but I didn't know it's technically called faster RCNN. No idea that this existed. I asked ChatGPT, I need to train a neural network to detect the bounding boxes for columns of a page in a textbook, scanned textbook. And it says, okay, yeah, train this model. And then I ask another question. Okay, this is the type of data I have. Write me a script with all the code I need to do this. And it's like, okay, here's all the code you need. So I think a very powerful tool is for people to know how to run code. And a lot of people never really had the need to, because then it would involve having to write code. But I'm trying to convey to people that you don't need to be able to write code in order to download it from ChatGPT and run it. And you can very specifically request exactly what you want it to do, what language you want it to use, etc. And again, I recommend people, if you're looking for programming languages to use, I recommend web stuff, HTML, CSS, JavaScript, and jQuery. And then for backend stuff, PHP and Python are my favorites. Okay, so let's see here. This is my utils. I think I already... Okay, no, I didn't. And let's see what it said about Cocoa. If you're not using Cocoa dataset, you don't need it. Okay. So now it's giving me engine.py. Okay, we did have an engine.py. And then train.py. I think I called that something else. Maybe not. All right, so let's see. This is my engine.py. Took some lines off. Then I have utils.py. And then train.py. which I'm calling run model training.py. Okay, so let's set up the images folder. What I want to do is I have something called scripts dir that I use a lot. Let's do find all in open documents. Oh, that's not right. Script dir. And so I just usually find an example of this somewhere and copy it. So we have to go get those images of, we'll call it so let's call this image dir path. So whenever you're programming, just to probably anybody watching this already knows, but anything where you have an equal sign, you're setting the variable value equal to whatever's on the right. Sometimes you'll see two equal signs. That means that you're checking if something is equal to something else. So very different meanings, even though they both use equal signs. But we're just using one equal sign, so we're setting this variable equal to whatever this is over here. And what are we looking for? We're basically joining the path of our script dir, which in this case is this right here. But this is the best way to write this because in the future, if you just copy it to a different folder, it'll still work. And then we're going to add here ASOP. So we'll make a folder just for ASOP's images. And then we'll change this here. Now, book page dataset train. Okay, so there's the same function call here, but there's a parameter that basically requests the training set or the validation set. And that's a very common practice. We've talked about this before. We don't want to use all of our data just to train. We want to save some of it so we can see how well the model is actually working. Okay, so the annotations file, let's actually change the name of this. Instead of output, we'll do ASOP transformations, or excuse me, annotations. And we'll put that here. And let me go grab those images. What was it? Images ASOP? No, just ASOP. It's fine. And we're going to have something similar for the other book that I wanted to train on. But let's try that out here. Also, let me make another note. That package that I tried yesterday was a little bit annoying because it reinstalled Torch, the CPU version, and it uninstalled my CUDA version. So I really don't like that library we tried out yesterday. I was hoping it'd be better. We did it live, and I'm going to give it a thumbs down in terms of at least my ability to utilize it. But it's always good just to try things out. There's something called virtual environments for Python, which is probably what I should have done instead of globally installing things. That way, your dependencies and stuff can be separate project to project, but that's more advanced. All right, should we try this? Fail early and often. My motto. So OS is not defined in run model training. That's fine. We can do import OS. No such file or directory. Okay, that's because we need to do it relative to the scripts file. It's probably looking at my user directory. So annotation path, annotation path. So we just append after the script directory the JSON file name. Try it again. Also, just keep in mind here, this is with word wrap on, which I like because I can see all the code at once. But if you're not used to word wrap, it kind of looks weird because you're like, why is it git transform here? That's part of line 17. If you look on the far left, you can see the line number, and that tells you which lines are split and wrapped. But it lets me see all the code at once. And you. So we try it again. Fail early and often. Okay, looks a little better. It's downloading something. So it downloaded the PyTorch model file for faster RCNN. All right, so at this point, I don't want to keep going back and forth with ChatGPT because we've already gone and changed the code and made changes on the files that we've downloaded. So at this time, I'm going to go to a new tab. Control K starts a new ChatGPT. And this is what I like about the placeholder saved query approach that I do. So let me show you how this works. I'm going to refresh this. And you don't need to build a whole page around this. I'm going to actually publish this at some point. But it's easy to write your own version of this. What I'd recommend is just have like a file with your query. So let me show you what that would be in a second. So the way it works for me for this, which is kind of unnecessary, is I check the files that are pertinent. Those are the ones I just downloaded from ChatGPT. Then if I hit X, they're all over here on the left. So what we do need and what you'll need is, and you can just copy and paste what you need into the prompts, that's fine. But what I like to do is have saved queries. So what I'll say is, grab some text here from this initial prompt. And I have something called globals, but I don't even need to use that. I'll just say, I'm working on a series of Python scripts. Let's do classes and scripts to train a faster, okay. And then what I do is I basically just drag them over here. I'll put that one last. Or maybe I'll put it first. And you could just do this in a text file and then have a script that grabs the latest and puts it in another text file and copy and paste it. But what I'm going to hit this button here, so it'll keep polling for the latest versions of these files. And I can click on them and look at them. It's a little... I was thinking of like having a much more enhanced version of this page here. But mostly what I need is just the copy prompt here. And let me, before I forget, let's do save query, complete code. Okay, so if I hit the copy button, I can just go straight to ChatGPT, but I want to show you in Notepad++ what I do. So for each of those placeholders, it says, here is my complete code, or my complete file, and it gives it the name of the file. And then it gives it the file. Here's my complete file, transforms.py. So it knows the names of all my files, and it grabs the latest and greatest, the last version of the code. And actually, whenever I make a change to a file, it's saving a backup of everything into another folder when I have this record on, which is nice for peace of mind. So let's go to that new ChatGPT. And at the bottom here is where I'm going to put my complaint. And the complaint is that error, I believe. I'm getting this error message. And the other cool thing is, you could probably guess, but I don't need to send it all the code. I could make different views into my code base in my saved queries. Did it not save? Okay, I just need to make it more responsive in the future and auto refresh, but I could have just my main training file and model and engine, for instance. If those just make sense, that sometimes I just want to send to those three. So it's saying, here's how you can modify the metric logger class to add the add meter. All right. So it definitely took some code away. Metric logger. Okay, just this part. So sometimes you just want to be very careful that you're not removing any key code. Do anything too drastic. So I'm just going to copy the part of the code that is the class. So something that's important about Python that you might not know is that everything is based on indentation, which when I first started, I found very frustrating. I think because I came from a bunch of languages that used curly braces for closures and for for loops and for just all the different types of closures. And so it was just a paradigm shift. But it's very picky because that's like part of the scripting. And so you could argue it makes it easier to read or harder to read depending on your preferences, but it is what it is. I have a lot of respect for the Python programming language. It's grown on me. All right, let's try it again. So we're getting some errors here. Just going to throw this all back at it. And I could download the latest version of the code, but since I have a pretty short message chain, I'm just going to follow up. Since it'll know what it just told me to make a certain change. And so it says the error you're encountering is due to the way multiprocessing is being handled on Windows. Windows does not use fork to create new processes. Here's how you can modify your run model training.py. Sorry, I wasn't showing my screen. To include this guard. All right. So it added a couple lines. And let's try this out. We might have lost that shell. Try this again. So what's interesting is I'm seeing that it's using Cocoa. I see Cocoa in the model name. I'm wondering if at one point I was thinking of using Cocoa format. And then I'm like, oh, I see here it says I can just use CSV. And then it said, okay, use JSON. So I'm not sure if that was a mistake to stray from Cocoa. Okay, this is interesting. I think that was the first in our list of files, page 452.jpg. So why did it not find that? ASOP, page 4, oh, .jpg? Should be .png. Yeah, that would be the problem. And I think that's in the annotations. I could just do a Control H to replace all, but let's go to the PHP file we wrote. Okay, I bet you if I change this. And actually, I needed to rerun this anyway because we made some improvements. It's good to have like a pipeline, a good flow that we can use. So if I just hit up arrow a couple times, we'll get back to this copy. And then if we... Another thing when I'm coding in Notepad++, I just like to move things that I'm editing over to the far right. It just helps me keep track of everything. So there's not too much scrolling around. Okay, so let's go to this page here. I'm just going to redo this blob of JSON. And then I can rerun this PHP, and this is why it's good to always just have the copyable run command. Okay, so it saved it to output.json. I can just do Control O, find what I'm looking for here. I'm going to hit F2, helps me just rename stuff. I'll just rename this to old. And then we'll rename this to the file that it's going to be looking for. But it is good, right? It started looking for this JPEG image. It's actually a PNG image we're looking for, though. So we'll try this again. It's taking a second. Oh, there it goes, epoch 0. The learning rate is 0.00014. The loss is 1.3688. Okay, awesome. Look at the loss is dropping. That's a good sign. So the loss is down to 0.64. Still on epoch 0, which is good. So I see it's at 10 out of 547, 20 out of 547. The loss is dropping. That's great. Boom, down to 0.1836. So the lower the loss, the better. While it's working on this, let's go prep the next data set. So this Greek data set here. Now, one problem I'm starting to see that is kind of an issue is we want to have access to all of the books all at once. So we need to reorganize. But let's start here. So if we go and copy this, reload that, so the PNGs. I'm gonna save, or I'm gonna do a rename on this. Rename on this. Call crop rules. Let's do ASOP _ call crop rules. And then this one will be Greek lexicon _ And then we have to update our PHP here. And, you know, by we, I mean ChatGPT. So let's go to ChatGPT again. Control K starts a new chat. We need to enhance this to work for multiple books with conflicting image file names. I have 2 books, and we'll grab some information about those. Let's do copy as path. In the JSON format, ready to go. The images for this one will be in the folder ASOP. It's kind of hard to spell, isn't it? ASOP. And the images for this will be in Greek lexicon. Let's define the books in an array at the top of the script and make sure to include the folder name, the respective folder name. In the annotations, which should include the info for both books. And I'll be adding more. Let's see how the script's running. Nice. This is actually really impressive. So the loss is down to 0.0821. Now, I haven't done enough experimentation with this type of model to really know how loss correlates to performance. Maybe it's going to be way off, but for a neural network, that's pretty good. Oh, shoot. I jinxed it. We got an error here. Okay, so try to find page 0.png. Why is it, at least it's not a worse error. That's something we can deal with. Why is it looking for page 0? Page 0. I mean, we checked, what was it, page 171, and it was right. Let's just try searching for one of these numbers. Okay, so let's try the page 0 number. It says page 0 has 2 boxes. Also, I thought I requested only... There's a number of problems here. I requested a page range that certainly did not include 0. Okay, here's the number. Okay, so start at 0, go to page 16. 0 in this case is more like just everything, not literally that there's a page 0. Okay, so a couple of problems here, but we were actually just talking with ChatGPT about this, so let's see what we can do. There also seems to be an issue where it's not... It's not respecting the include page ranges, which along with include pages are the only pages which should be in the resulting annotations JSON. Also we need to set include exclude ranges for each of the books separately. All right, just going to take a shot at it. Let's eyeball it first. So we have the books, each with their own page ranges. Let's make sure that those page ranges go to, let's see, should include range and page. Include page. Okay, it looks better. I mean, isn't this impressive that it can do this? I mean, it makes mistakes from time to time, certainly. Leaves a lot to be desired. But I'm seeing a little glimpse of the future, I think. All right, so this is my PHP script. The other thing, I wanted to make sure that we get the page ranges. Okay, it's pretty easy. So Aesop's easy. And for Greek lexicon, it's a bit trickier. I have already a couple of pages that I know for some reason got really washed out. Let me find my list somewhere. There we go. Just 3 of them. And we'll let this load as I put these in place. All right, so the Greek lexicon crop rules here. These are my exclude pages. And let's get the range here. There seems to be a bounding box issue I've got to fix for really small. Hopefully this doesn't break it. Should only be when I drag that it updates it. I think there's like 800, or what was it, 928? I think there's a couple blank pages at the end. I went through and I made sure these were all aligned. I'm still got to iron out all of the kinks. There might be some minor bugs here. I mean, I'm sure there's bugs here and there, but hopefully we get the gist of the crop regions. Come on. All right, I'm just going to go off the, oh, there we go. Okay, the last page is 918. The first page is 23. We can even include 14 to 923. All right. Let's try it. Okay, it's got the book name, which reminds me, we need a new folder called Greek Lexicon. And we need some images in there. We'll get that thinking in the background. Okay, let's make sure there's no page 0.png. Ah, shoot. So let's, since I made some manual changes, I want to copy this back to, okay. I changed the script to make it more right, but there are still issues. There is a page 0 for Aesop. Sure, we can find more problems. Page 1. Let's just say, and many other pages out of range from what I actually requested. Please fix. See what it comes up with? So it says it's going to put some output. All right, let's grab this. All right, don't have much faith. Okay, actually maybe. Okay, there it goes. So let's see what, well, I'm seeing page 19 on here twice. Some more issues. I'm seeing page 19 for Aesop twice. I think there's a misunderstanding. We are specifying rules for pages, and some pages may be in multiple rules, but we should always prioritize the top page, or the top rule, i.e. first in the array. The script should iterate starting at the pages specified by the include exclude ranges and page number list, and then find the top priority rule for each. Don't duplicate. Make sure to pick the best rule first for each page. All right, hopefully it gets it now. So this is the process at this point with ChatGPT, but it's amazing that it can even do this, frankly, because I never really explained that. I just figured I should have explained it. And we can say, well, maybe it should have figured it out. That would have been great, but I can see how it wouldn't understand if we don't tell it, right? All right, so let's try this out here. This is my PHP. That's not right. There's only 30 pages here. You ruined it. Much worse. Now you're just doing page 1 for each book. And that's not even in either of the include lists. Exclamation point. It's funny. So we can always just undo a little bit if it goes off on a tangent and starts messing up too much, but I feel like we're close enough. It should be able to get this. Okay, looks better. So 18, 19, 20, 21, 22, all the way up to 532. Is that right? $532, 18 to 532. Let's see, Greek lexicon. Should skip number 40. Nailed it. All right. Nice. So now let's just rename this as annotations. So we've got to go change the main script here because we want to use both books. Because at this point we have, let's see, if we just do a count on how many times we have images colon or image colon, we have 1,422 things to train on and validate with. Or validate with, I should say. All right, so let's go to the runner, run model training. This time we just want to do annotations, not ASOP. The image dir path is just script dir at this point. Although I hope it can handle having a slash in there. Just thinking about that. Okay, and we can just always go update book page dataset if it doesn't work. And is that it? Let's just try it. Fail early and often. It's the best way to succeed. So we'll let this think. I'll be right back. All right, off to the races here. Starting good. Already down to 0.22 on the loss meter. And it seems to obviously be dealing with the complexities that we've added. And now it should be able to find all the pages. Maybe we should look at the code that we're running. So it splits the data set into train and test, loads it up, then it trains the model. It's using CUDA, so let's just to check out my measurements here. You can see that the 3D is doing the bulk of the work here. All of this type of work is delegated into that 3D category. I believe this video encode is because I'm streaming at the moment. Okay, the loss is down to 0.1135. So all of these are tunable parameters. It's using stochastic gradient descent optimizer. It's going to do 10 epochs, so it might take a little bit. And then for each epoch, it runs this function train one epoch, which is in our engine. Let's find that. Train one epoch calls train. So this is interesting. When you call .train on the model, technically what you're doing is you're just marking it to be in train mode. So that doesn't actually do the work as one might think. There's also I think it's eval. And when you run .eval, basically you're putting it in performance mode. And then there's, I think, like one of the main differences between train and eval mode is whether dropout is applied. So dropout is a setting that you can do that makes the model training more robust by just randomly turning off certain nodes. So it has to adapt. But you don't want it to do that for eval. All right, let's check in on the training. Not sure what the ETA means there. I'm guessing that's the rest of the epoch 0. Which I'm wondering if we should kill this off and do something with fewer epochs so we can get the result quicker. But I just find this fascinating. So we've covered all these different categories. There's numerical regression. There's text classification. Now we're looking at image segmentation, finding key areas in an image. I've seen people do some really cool demos with this. Like maybe we can pull that up on Google Images or something. But people will like do real-time analysis of like a soccer game or something, and they'll automatically detect all the players on the field, all the lines on the field that are of importance, the goals, etc., the ball. It's obviously a very capable model, and this might be one of the more easy tasks for it, because I don't know how easy this is for a convolutional neural network. I have zero functional experience with it. But let's see. It's called Faster R-CNN. And what's cool is we're doing what's called fine-tuning to a pre-trained base model. So let's see if we can find that bit where it loads the model up. Model equals get model, which is from our model.py. Get model uses what's called torch vision. Models.detection.faster RCNN ResNet 50 FPN pre-trained equals true. So I'm interested too in what is this model exactly. Real-time object detection. So it should be super fast once it's trained and you're just doing inference, predictions. Here's something. I don't know what that is. Drawing boxes around people. Let's search like demo. So I could see uses for this, say if you're a farmer or something, you have livestock and you just wanted to track them without like RFID chips or whatever. If you just put like a little cheap camera in your hen house or whatever. I'm just the reason I came across this is because I was like, it's interesting that we found that the other day that the person was using machine learning to detect the parts of a page for OCR. I just didn't really like the implementation. I feel like it wasn't exactly what I was looking for. So I was like, I've got to wonder what could be achieved. And with ChatGPT, we can actually just try it out. That's what's amazing to me. So you might be wondering how the run is going. We're down to a 0.0522 loss. And what's in the parentheses? Is that that might be the validation loss. We can look that up. We have the source code. Something tells me it's going to be this file. Let's search ETA : I think that's meters probably. We have some time to figure this out as it's plugging away here. Let's search loss. That's what I should do. Loss : Not finding it. Not sure. I'm guessing that's the loss, and then on the left is the training loss, and then the right would be the validation loss. Okay, so it finished the first epoch. Took it 9 minutes. Oh, got an error. Shoot. Something with the logger. So it's not even a big error, but all right, let's go back over here. This is why I like having this button, copy, and come over here, do Control K, start a new chat. I'm having an error with my metrics logger. We can also ask it about interpreting the, we'll start with this. Interpreting the output I had a question about. And we can also take this opportunity to do just like 3 epochs. I don't want to wait for 10 epochs. Let me take a quick second to remind people that we have an awesome website. I'm sharing all the great finds that I come across in terms of videos. It's groupdiscover.com. And a 50% off coupon code for new members. Just use the coupon code anti-poison. And then you can share all the documentaries and the videos that you find on there. And then all the members can rate them 1 through 5 stars. The best videos go to the top. People get suggested videos that are the best ones they haven't seen yet as per the community ratings. So it's a great site, and it keeps this work alive, which is desperately needed at this point. So thank you to the people who do support the channel. Very few and far between, but I do appreciate it. And if you want all my research, you've got to go check that out. And then also my Substack, timtruth.substack.com. I'm going to be publishing a lot of code because I'm just addicted to how easy it is to write code with ChatGPT. And so I'm just trying to dream up the best code for us. And then I've got to publish it, and just to pay for servers and stuff to host the code. I don't want to put it on GitHub for them to rip it off. And we've got to have some premium content or people won't support. Some people are nice, but All right, let's try this new code out for utils, I think it's in utils, metric logger. Don't want to lose anything. And let's also take the opportunity to just run 3 epochs. Or let's do 2 epochs. I don't want to wait for 3 and then have an error on me. Try this again. And we can take this moment too to copy some of this and ask it, can you explain this output to me? So the loss, the current loss and the average loss is what it says. The average loss up to this point. Okay, so that's even better. That the current loss is really what we want to look at. So it's firing up the engine, it's warming up here. There we go. I've also been, let me explain this a little bit while we wait. I've also been working a lot on the multi-dimensional or even single-dimensional neural networks, and I find it fascinating. And I've just been working out the kinks before I publish that onto Substack for supporters. And for example, I just found a little bug that I wanted to improve, obviously. When you do these neural network training rounds, it's oftentimes helpful to normalize the data before you feed it in. And it can increase performance like 5, 10%, sometimes more. And so there's a key problem, though, that I realized is if you lose the normalization parameters, which is like the mean and the standard deviation. If you lose those parameters and then you try to feed data into your model that you've perfected, and you're like, okay, make me a prediction for 4, the number 4. And it's like, okay, here's, it's 12. And then you check the answer key, you're like, shoot, how did it get this wrong? It was, I trained it like to a loss of like 0.00001, and it's way off. And I'm like, oh shoot, it must be a normalization thing. So the way I'm doing it now is I have everything tucked away and saved in the PTH file. And so it automatically loads up all these additional settings, like the architecture. So you don't have to remember, oh, I had 5 neural networks, then 10 in the second layer, then 24 or whatever. That's all saved. That's all remembered. The activation functions are remembered. The normalization is remembered. And I didn't run into this issue very early because I'd always have all my data and I'd feed it back in. And for example, I figured out the other day how to restart or how to continue the training from a saved file. So I train it from scratch, spend an hour training it. It'd be really good. And then later I wanted to train it more. So I can load it up, train it more from where it was already at, which is really cool. So if you have more data or whatever, you can continue the training. But then I wrote yesterday, I was like, okay, let's make a simple script just for making predictions, because that's a common task. Once you have a trained model, you want to use it, right? You spend all the money doing the training, is what they say, and then you make the money doing the inference, the predictions, at least if you're using it for business purposes. So I tried it out. I'm like, shoot, why are the numbers all off? But then I quickly figured it out. I'm like, oh, the problem here is I don't have the normalization numbers anymore, the standard deviation and the mean. So I was like, we've got to chuck that into the file, the PTH. So for all this code, I'm really trying to run it through the ringer, find problems with it. The next step with the neural networks for me is to try to get categorization stuff working, categorical features. And one problem for me with categorical features is I see them a lot in the wild when it's time to actually train a model. And I have numerical features and oftentimes categorical features, and then there's text features, which I like to use BERT for. But the problem with categorical features is, for numerical features, I can make stuff like this, which is really easy to visualize and understand. Even with a complex equation like sine x plus cosine y, I can wrap my head around it's a curved, what's it called? Surface? That's not the right word. But the problem is, like, how do I build categorical features into the data in a way that makes sense? I guess I could maybe use like Kelly Blue Book pricing data or something. Well, that's not even really what I want to do. So category is where you have, for the car example I just brought up, make would be a category. Although that gets tricky because there's different make series for each of the different brands of cars. So maybe all of them would be put together. In which case, do you need another category for... Actually, excuse me, I was thinking model. Model has a different list of category options for each manufacturer, each make. But I don't really want to spend time making a model to predict car prices. I'd rather do something more useful. Although, how I always recommend doing this is try to solve a more general problem. So you're not going to write a sprawling script just to come up with like car price predictions. I think that's a waste of time. Not a waste of time, it's a good exercise. But what's much more valuable is what I'm doing with, I've already accomplished it with numerical features, where you build something very generalized. Let me just show that real quick. So I can just use it like this. This is like a runner script. This first part is running it from scratch. All I have to do is specify the number of layers and how many neurons per layer. I've had a lot of success, interestingly, because I've read literature on this, with just a single neural layer, single linear layer with a lot of neurons. So this is just one layer with 1,000 neurons. But what I like is I can just pass it a CSV, and the CSV has X, Y, and Z. And then when I'm calling this in the code, all I have to think about is what are my numerical features and what's my target. So in the future, what I want to have, let's just search. I bet you'll have it somewhere here. And then it gets even, let me just show this before I jump around. It gets even easier when I'm further training an already saved file. So I have my neural network here. And all I have to do in this case is give it a path to my model, a path to the CSV that I'm training from. And then, importantly, whenever I have an existing model, I want to make sure I use my the original normalization parameters. I just want to keep that throughout the entire training of the model. All the predictions, everything uses that first set of normalization parameters. And so there's that. But what's also interesting is I don't have to specify the architecture. That's my config here, because that is stored in the model itself. So I can pick up a model later and just be like, okay, this is a pretty good model. Let's just perfect it. And I don't have to go dig in. I could easily find out from a model what the architecture is. And that's just in general with just a normal PTH, not even an enhanced one. I enhanced it to save the additional info. But my point here is it's best to make code like this. So you just have to pass it what changes from run to run. Sometimes it's called the business logic. And then you have everything else ironed out behind the scenes. So you and anybody you give the code to doesn't have to worry about it. This is the ideal. So what I'd want to do is add something categorical features. And that would be additional 1 plus or 0 columns in my CSV. But I need to give it a list of all the different values for those categories. And there's something cool in PyTorch. I'm asking ChatGPT, give me an example of training a neural network in PyTorch that uses an NN dot, I think it's embedding layer for, let's see, that uses let's do an example with 3 NN embedding layers for 3 categories. I want there to be 3, 4, and 5 dimensions for categorical embedding representation for these 3 categories respectively. And while it thinks about that, I can do a couple things. Let's check in on the model. How's it training here? Okay, we crossed down. Oh, we gotta. Oh, sorry, that's that's my neural network training. Let's go back to. Okay, so we got past the barrier that we hit last time. So we passed the first epoch. The loss is down to 0.05. It briefly crossed under 0.05, then it bounced up a little bit. But we're into epoch number 1. So we're just running 2 epochs, so it's not far from the end here. All right, and a couple other things. Let's look at how I define my categorical features in these other... I mean, you can see how much I program. I just sit around all day programming for... I consider myself the research arm of the... No, I don't even want to say the truth community, because the truth community has turned itself into a poison cult. It's been totally infiltrated. Of course, that's not real truth. Bunch of fucking liars, con artists, and worse, Jim Jones characters. So what do we call ourselves? I'm politically disenfranchised. Politically is the wrong word, but you get what I mean. All right, so what I'm looking for is, let's just search like Toyota. That'll help me find it. Actually, I know exactly where it is. Let's just go to that file. In projects, I have... Let's see. I think like gradient boosting would have it. Yeah, right here. So I wanted to find it somehow like this. Categorical features. So just like before, we'd have numerical features, X and Y in our other example. Categorical features, these would be all the different categories. In this case, there's 5. Brand, and then there's all these options. And the way it works with neural networks is it maps these to just a number. And so you keep track of your list. You don't want to lose the list or lose the ordered values. But behind the scenes, it just looks at it as a number. And then what's cool is, I think the best practice way to do this is what's called NN.embedding. So we've covered previously about how NN linear works. So NN linear, let me add here. Whoops, I meant to say, to also say we have 10 numerical inputs. But we can look at this in the meantime. So in this example, it's all categorical inputs. So the linear layers, we've talked about that a lot. Like this here has 1, 2, 3, 4 linear layers. And yes, I counted that right. So the linear layers are between these columns of neurons. Neurons don't actually exist in the implementation of these models. The neurons are just like the space in between these linear layers. So it takes two parameters, two numbers. The left is the number of ins, the right's the number of outs, and it's a fully connected meshed grid there in between all the ins, all the outs for each linear layer. So in this case, they would say you would draw 10 neurons, but really the 10 doesn't exist. These two linear layers exist. I mean, I guess you could say the 10 neurons exist, and each of these linear layers consists of a matrix multiplication and then a matrix addition. So it's super fast to do. Even when you're running, let's say, 1,000 numbers through your neural network, that's just one matrix multiplication, one matrix addition for each of those linear layers. All right, so this is the update here. So now we have, this is the update. So their example here that we have 10 categories, 10 classes in category 1, 10 options, 15 in 2, 20 in category 3, and then we have 10 numerical features. And so how many inputs do we have is the question. Well, let's look here. It's a bit confusing, isn't it? Let's see. Where's our neural network defined? Okay, up here. So the NN embedding helps us. Basically what it's going to do is, as we train our model, it's also training how to represent each of our categories. And the categories are represented as vectors or as lists of numbers. And we can define how many numbers it takes to represent each category. So we've talked before about one-hot encoding. One-hot encoding is one way to represent categories. So in this case, if we had 7 categories, we could represent it with 7 different input nodes and just fire one hot value, or the one value. All the other ones are 0. But we can actually do different approaches than this. And so what I'm finding is this is probably the way to go, NN embedding. And so what this does is it sets up a little bit more interconnections and things that it can train along the way. And what we're training is how to represent, in this case, 10 options for category 1 as a 3-value list. So then for the second one, we want to have it in 4 dimensions, and then the third category in 5 dimensions. And so whenever we init inside of something that extends a neural network up here, where you have a class and then in parentheses nn.module, this is where we set up all of our layers, and embedding is a different type of layer here, NN embedding, then our NN linear. The NN linear layers takes 3, 4, and 5, which are the number of dimensions we've reduced the embeddings down to. We've represented the categories in 3, 4, and 5 input flavors. Or what do I want to say? Basically, we embed a category, and depending on how we define up here is how many numbers it takes to embed the category. That's probably the best way to say it. And so when it comes time to our first fully connected linear layer, we have 3 inputs for the first category, 4 inputs for the second category, 5 inputs for the third category, and the total number of numerical categories, each with 1 per. So this is just to make it easier to read here, 3 plus 4 plus 5 plus non-numerical. But you could write this a number of different ways, right? And then we map those all to 10 nodes, 10 outs, which we have one more linear transformation, which maps it down to a single output. And it says for binary classification, but and that would be yes or no, right? Yes or no, or category 1 or category 2. But with a single output, you can also do numerical regression, just predicting numbers. And then when it comes time to do the forward pass, we'll come back to that. Let's see how our training is going. Looks done. Okay, it finished. How'd it do? It got under 0.05 for the loss. So now my question is, how do we use it? How do we use it? So I'm curious, like, how it can do on a given image, predicting where the columns go. All right, how do we do this? Let's see. So let's go to our project folder. Actually, it might have saved it in my user documents. Okay, I don't even know if it saved it. Let's figure out what happened here. I don't think it saved it, which is an issue. So I'm glad we didn't do too many epochs. So let's go to let's copy the latest code. I have this code, but it's not saving my model. So it says to use torch.save, which is fine. Usually, though, I like to customize and do it as part of the custom class. Have like a save function in the custom class. It's a shame that it didn't do this as part of the initial code. I should have checked. All right, so at the end, it's saving the model. You can see it's saving a number of details with the model. So you can save related information. So it's going to save it into our save dir, which is going to be the model checkpoints. Okay. Oh, I didn't show my screen. Sorry. We'll look at this here as I paste it in. Okay, so let's take this, paste it into place. This is the save part. As you can see, it's saving how many. It's saving additional information along with the state dictionary, which is the most important thing here. We really don't need to save how many epochs, but that's fine. And let's just fire this off, and then I'm curious about how do we make predictions with it. So we'll ask that while it's thinking. All right, so if we come back here, can you write me a Python script that will load up such a model and make predictions for 5 images from their absolute paths for, can't type. For example, I'm just going to get 5 images for it. And I should probably use pages that we haven't seen yet. Let's try this book here. Actually, this looks a bit strange. That's got a weird structure. Let's see what else. I think this one might have 3 columns. I'm curious how it does with 3 columns. Because we didn't train any of them. None of our training data had 3 columns. So, it's a similar pattern that we've trained on, but it's also totally novel. So let's try with these, and then we can also pick different ones. Remember, it's super fast once we train the model. So let's do something similar, but in this case, run model predictions.py. So got to copy this in. It's done. I'm not sure what this is. Num classes. 1 class text column plus background. What is that? Okay. So that's fine. Just to confirm, so it can detect multiple columns though, right? Why is it updating this? Yes, the model can detect multiple columns within a single image. It's designed to handle multiple object detections. And it will output bounding boxes for all detected objects. Nice. All right, let's go back, get this code. Actually, I already got it. What we need, though, is the PTH file. That's the model file. It's also amazing. I've been seeing PyTorch everywhere. I've been taking interest to these people who do AI art, and you see PyTorch a lot with that. For example, if you were to try to make a diffusion model from scratch, a lot of times it would be PyTorch. Let's see, write me a... And diffusion is cool if you haven't heard of it. It starts with like a pixelated, just a noisy image. It's like staticky black and white. And then it's trained, the model's trained to remove noise in the direction of whatever your text prompt is. Write me Python code to train a diffusion model using annotated images. Let's just run that, see what it comes up with. Yeah, it says use PyTorch framework. Torch Vision again. It's not really giving us much code there, but kind of skipped the main part here. Define your network architecture here. This was the key part you were supposed to write. So this is double convolution model, down and an up model. Here's the diffusion model, which includes these custom parts. That's interesting. So I don't really have any need for image generation, or at least beyond the, I just, at this point, the most sensible thing is to either in my opinion, I don't want to say that too drastically, but I don't have a need to like generate images personally. I think it's a very interesting space, but I'm more into using this technology for research and publishing and helping people find and discover the most important knowledge buried away in huge archives. But I do also have a need to make images for like thumbnails and such. But it doesn't make sense for me to train a model from scratch to do that. Just use the best options that are already out there. But what else was I going to do here? I kind of want to ask for what is PyTorch and why is it so important for machine learning? I see it everywhere. And I think it's because it leverages CUDA and it allows you to do matrix multiplication really fast. It's for building and training neural networks in Python, obviously. It's not too helpful of a response, but okay, let's go back to the model training. We're about to be done with the first epoch. Very curious what's going to happen when we do predictions. And I'm also interested in like how useful this will be to say this task that I'm working on, which is how do I extract data from, say, millions of PDFs. And I'm also interested to think about the best way to use a trained model, be it BERT or neural network or RCNN or faster RCNN. Especially if you have a ton of records. I think it's got to be a cyclical process where you start, give it a best first go. How much can you sit down and label in a sitting or two? Train a model off that. And then use that to give you a starting point for the next batch. And then you should just, have to tweak, hopefully not too much, or the first round of training didn't work too well. And then each round you just continue, you have more training data. And that training data keeps growing in quality and quantity. And then you can retrain and the model should get better. And then as you work through the huge data set, it should get easier and easier and more completed. So we're into epoch number 1. This is the final epoch. It's interesting because it seems like it almost hits a wall. And it's probably because I don't have too much variation in the data. But it seems to learn it pretty quick. And then it kind of hangs out around the 0.05 loss. So we can see a big drastic drop off, which is good, up until epoch 0, about halfway through the first epoch. Actually, much further than that. It's still, oh wait, I'm looking at the average. Of course, the average is still dropping. Yeah, about halfway through the first epoch, and then it kind of stabilizes and plateaus. It's also interesting to play around with the learning rate and see. So right now we're set at 0.005. It's interesting to try like, okay, let's try 0.01. Let's try 0.0001 and just see how how it affects things. And it's also a good idea to make it so that you can train models in bursts. So you can do a high learning rate to get started and then maybe turn the learning rate down, really get the fine tuning. I was also experimenting. I didn't have much luck, but I was thinking it'd be kind of cool to have a GUI, a graphical user interface, for training a model, whereby you could see and change the learning rate as you go. Okay, we're actually, maybe I'm speaking too early, but we're down at, okay, I did speak too early. It looked like it was going down almost below 0.04, but then it bounced up. Okay, there it is, 0.035. It's the best we've seen. Bounced up again. So let's ask a question to ChatGPT while we wait the home stretch here. How do I interpret a loss of 0.05 in a RCNN or faster RCNN model I'm training? So it's interesting, there's these different measurements, and it kind of combines all of them to a total loss. If your initial loss was 2 and it reduced to 0.05, this is a strong indication of model improvement. Well, we definitely had a big reduction in the loss. Started at not quite 2, but 0.8. So this will be the last thing. We'll wait, and hopefully it'll print out, save out the PTH file, and then we'll run the prediction, maybe on a couple of different sets of images. The first ones I want to try is the one with the 3 columns. See how it does with 3 columns, which none of these examples had 3. But that should be fine because, for example, it has the ability to, I've seen it do cars and people, and it can do as many people as there are in the frame, as many cars as in the frame, once it learns the pattern. And again, I've shared a lot of really interesting videos on groupdiscover.com if you want to join me over there and share whatever you find and keep this work alive. Any support is very, very greatly appreciated. I'm trying to go a new direction in terms of the content I'm making. I'm just sick of con artists pushing poison on people. And I want no part of it. No part of it at all. Other than calling it out and exposing these bastards. That's the part I want. And it's so obvious. I don't know how people can't see it. I don't know how people can continue going back to someone trying to trick them into killing themselves. It's really pathetic. And, you know, shame on the people perpetrating this scam, this crime against humanity. Beyond shame. I wish nothing but the worst for all of you. And let me know in the chat if anybody has any questions. Shout out to anybody who joined us here today. Hopefully we'll have a good finale here for everybody. As always, seeing some bad takes on AI in the chat. Nothing new there. People afraid of math, like, I don't even know what. No, I don't want to have a system that can just do all my work for me. I want to slave away on my own. Okay, home stretch here. Last couple of seconds of the model training. Hopefully it'll save off this PTH file, which is the file extension for PyTorch models. And then we have another script ready to go. Let me copy this path here. Actually, one thing I forgot to do. Actually, no, I think it works. It'll put it in the model checkpoints, and then got to change this here. We'll do that. All right. And we'll copy this. All right. So it's interesting. I'm just noticing now, after the epoch, it runs the validation step. I don't see any measurement for accuracy of the validation, but let's just run this predictions. Okay, messed something up there. Dot path to be os dot path. Take two. Torch vision is not defined. We'll just complain at ChatGPT. Shouldn't just be from torch vision import transforms in torch vision? Might not be right. All right, let's see. Here's what I'm trying. I get the error. The moment of truth. What does everyone think is going to happen? Okay, so I think I just need to do import torch vision. Standalone. That makes sense. That's interesting that it's downloading something here. No such file or directory. It's because it's another folder I'm missing. Take 3 or 4, I forgot. Okay, so we got some predictions. So, seems like a lot of numbers here. 1, 2, 3, 4, 5, 6 for page 45. Let's see what that page is. So this is page 45. Definitely only has 3 columns. So let's open this in GIMP. It's like free Photoshop. And let's see what these correspond with. I'm a little disappointed. Why is it finding 6? Well, maybe some of these are the backgrounds. Oh, that's probably what it is. So let's just complain to ChatGPT a little bit here. Because remember, it says it's trying to find backgrounds and columns. So the output is very confusing. I imagine because these are the columns and the backgrounds. I just want the columns output / print it. So it has some idea here. It says use a threshold greater than 0.5. Sounds like a plan. Rerun this again. And an error. It's because it reverted back. I need to put the extra folder path. That's a little better. Look at that. So page 45, it's giving me 4 results. And we have this open here in my text, or my image editor here. So let's draw this. So from 90, let's start this here, 92 and 278. Let's see, hopefully it's around here somewhere. (92) 278. It's hard to find the exact spot here. It's somewhere around right here where my dot is. Not going to worry too much about it. And then if we scroll down here, it's actually confusing with this format, because I'm going to do some addition here. Basically, it says, I mean, that's about right, I think. It's hard to... Okay, let's go to ChatGPT. This is where ChatGPT is great. First of all, I'm tired of making this change. You have to change the line to this. Or I could just copy the model file. I'm curious too how big that model is. Uh, 322 megabytes. Okay, you have to change the line to this. Also, can you extract the matching, or maybe we should just have it draw red squares, red rectangles. Let's do that. Can you make a copy of each of the images into Scriptr and draw red rectangles around the matching border boxes? So we're approaching what many people are wondering if this morning may bring GPT-5 or the next iteration, maybe GPT 4.5. So we'll be keeping a close eye on that on this channel. You know, the whole economy changes, the whole world changes depending on how powerful the latest models are. It's really crazy. And I worry people are going to be falling behind. But everyone's choice, I guess. Intellectual freedom movement. All right, hopefully this is making a copy. Nice. All right, so let's see how we did. So there are some problems here, but it's interesting that, let me show the other screen. Definitely some weirdness. It got the first column pretty good. Then this box here is really big, and then this one over. So I would call that a fail, but it's kind of starting to guess. Remember, we never trained on anything like this. Okay, that's really bad. I don't know. There might be some logical issues with the bounding box drawing. Dang, it's not very good. But again, we didn't train on this type of book. That one's not as bad. That one's closer. Okay, let's try a book that is closer. I mean, we could try the ones that we actually trained on, but that's probably cheating, right? So let's try, see if we can find another one. In the Aesop book that we trained on is probably not the best example because that's just one column and see, maybe this, let's try this book here. Take a couple of pages out of this, copy the paths. I do think it did better than the one we tried yesterday. And we didn't train this on too much stuff. So I don't know. I probably won't pursue this too much further because it's not, I don't know. It doesn't really meet the grade that I was shooting for, to say the least. Okay, so it messed this first image up. Page 52 looks pretty bad. It got, I still want to see the boxes it drew. And it was a good learning opportunity here. But let's go to where we're looking for. Let's just open all these up. That's pretty good. I mean, it's not perfect, but maybe as a good starting point. And also the way that my I mean, that's actually kind of impressive. I'm actually genuinely impressed. That's a win right there. And the way that I would probably read this is like, okay, there's two columns, and then this is the major bounding box around the outside of both of them. That's how I represent it on the page that we were looking at earlier. I don't physically have two rectangles floating in free space. I have one with a sub box. Okay, now this makes sense too. Although there is some extra stuff going on. But again, like, this is kind of an outlier page here without much of the training data discussing this. And so this is the thing, if you have a billion rows, a billion records to train on, be it text classification, numerical regression or image segmentation or detection, if there's a adequate enough architecture and it can actually learn, then there's a way to kind of do a cyclical process where you just do in batches and then you have it automatically guess and then you do the corrections. But these other three are fairly impressive. Not perfect. But what I really like is it skipped the top text, which is what I always do when I'm cropping the images. I don't want it to have this text up here. So we'll wrap it up there. I think that's actually a pretty interesting video that we just made, all in all. I think we covered a lot of how to use ChatGPT to write code, how to execute Python code, the difference between... Oh, I didn't even show my stupid screen. I'm sorry. We've got to spend some more time covering what just happened because I wasn't showing my screen. Shoot, sorry about that. Here's what I was discussing. You can just take my commentary and apply it to the visuals here. Like, that's a success right there. That's pretty good. And you can see how it doesn't get the top word here. Now this one, I mean, there's definitely flaws here, but the more you train it, the better it'll get. Wow, so just another tool in our tool belt. And what's cool is now I have kind of a pipeline and some code laying around that I can just hit the ground running if I ever need to use this in the future. But sorry for not showing my screen there for a second. This is what I'm looking at. This was the weird one here. But you can see kind of why it's weird. Because there's a change in the letter from A to B. And a cutoff in the... I mean, there's some weird stuff going on here. Like there's a big box. Or I don't even exactly know how these... it probably would have helped to pick random colors instead of red. But these others worked much better. And match what we trained with more. So all in all, we got mixed results. I think it would have done better if we trained on more with like that white background in the 4 columns. But I call that... Oh, I'm gonna declare victory. I'm not gonna use it, but it's cool that we can whip out a vision model, train it a number of times, work out the errors, write all the code from scratch, and these language models are only going to get better and better, is my guess. Actually, that's probably not true. For a bit here, they're going to get better and better. So I think there's a window for us to grab as much code as possible. What happens after that, I don't know. I see a lot of psyops coming. I see them saying, oh, energy's so expensive now, and we have to ration the energy, and nobody can train their own models. You have to use GPT, and we have to make it extra safe. Wink, wink. And, oh, let's use it to make our political decisions, and, oh, let's make it tell us what to do about the climate, et cetera, et cetera. They're so obvious if you just listen to what they say, what they're going to do, if you know what's going on. So I appreciate everybody stopping by. If you found this interesting, good. I hope you found it interesting. If not, that's fine as well. And I hope everybody has a great rest of your day. Check out groupdiscover.com. Check out my Substack. I'll be posting more code onto my Substack for supporters. And I really appreciate you all. Take care.